A very warm welcome to all CMA students to Mickey's classes. We have, in our last video, we have already discussed about planning and budgeting. This time we are focusing upon forecasting. Let's move on. And by the way, the contact details are mentioned in the slide. You can check the email ID. You can check the website's address and the contact number. Please do get in touch. Forecasting techniques. There are two basic forecasting models. One is called as time series method. One is called as causal. This is not casual. This is not CASUAL. This is not casual. Okay. This is causal. What is causal? Causal. Okay. Causal is basically cause and effect. Cause and effect. When we discuss, you'll get to know a little more about it. But basically, there can be two forms of forecasting. One is time series method, one is causal forecasting. Within that, there are different methods which are used. Okay, let's progress. Time series analysis. This uses past patterns to predict future results. So what is time series analysis? It uses past patterns to predict the future. Okay. And what does that mean? Let us go to an example to understand a little better. Okay, let us take an example of car sales in units. So on the y-axis, we've got number of cars sold. Correct? On this axis, y-axis. X-axis is the year. Which are the years we have taken? 2000, 2002, 2004, 2006, 8, 10. Right? Okay. And then this is the volume of, this is the number of physical units of cars which have been sold. Let's say this is, and all of these are in thousands. Which means what? Suppose this is, let's say 50. It starts from here, goes up, keeps moving up, keeps moving up. This is how the graph for car sales is going. Okay, so if this is 50, let's say reaches here. So this is somewhere around, let's say, I don't know, might be somewhere around 55,000. Then 2004, it goes up till here about. So this is, let's say, if this is 55, this is about 70. Yeah. So let's take this is about 65 maybe. Then this is 2006. It is again gone up marginally. So this is maybe 70. Then 2008, again it has gone up. So this is maybe somewhere around 80. And 2010, it is somewhere around here. So about 85 or so. I know the numbers which we've taken will not be exact in terms of how much has the curve, how much has this gone up by, right? But I'm just trying to give you an idea of how this is done. So y-axis has the number of cars sold. So this is all in thousands, 50,000, 55,000, 65,000. How? Portray this graph on the basis of the years. 2000, this was at 50, 2002 at 55, 2004 at 65. Let's remove this small thing here. 2004. Okay. 2006 at 70,000, 2008 at 80,000, 2010 at 85,000. And we see that within that, there's a lot of movement which keeps on happening. There's a bit of the cyclicity is there, right? At times it goes up, at times it comes down, but generally speaking, it has been moving up all along, right? So now going back to our slide. So in the case of time series, we discussed this uses past patterns to predict future results. So this is the past pattern which we have for car sales. So suppose we are asked to make a projection for 2012 on the basis of what we already have here, right? And let's say the graph was only till here. Only till about 2010 and not too much beyond that. So we not have the figures for 2012. But on the basis of this history which we have, on the basis of this entire history which we have up till 2010, from 2000, we will try to make a projection for how much will that be in 2012. So this is what is called as time series forecasting. Time series forecasting. The important thing which you need to observe over here is we have just used one variable. This is called as the dependent variable, and this is called as the independent variable. What is in the x-axis is called as the independent variable. Independent variable. And what is on the y-axis, which is car sales in units here, is what you call as the dependent variable. Fine. So this is what is called as a time series. What do we do in this? On the basis of the car sales, which has happened in the past 10 years, and the pattern which we find out, and the pattern, we are going to make projections for 2012, maybe for 2014, maybe for 2020. Okay. So that is what is time series forecasting. We have taken one variable, which in this case is car sales in units, and we have checked how much has it been over all of these years, and on the basis of that we're trying to project further on. Okay, this is time series forecasting. Okay, let's go back now. The components which a time series might have are, so these are the components which a time series might have: trend, cyclical, seasonal, irregular. Let's find out what these might be. So now we have this pattern which is already there for car sales, right? So you'll find out that as we discussed, so this keeps on moving. See, at times it is right up here, at times it's down here. This is called as a peak, and this is called as a trough. These words are not important, but what I'm trying to show you is there's this kind of cyclicity. It's coming down, it's going up. Okay. But over a period of time, you find out that from 50, car sales has moved up to about 85. So if you join the 2 points, let's say, from 50, it has gone up to 85. This is what you call as a trend line. This red line is called as the trend line. I haven't exactly used the mathematical formula to find out the trend line, which I'll tell you later. But for now, what is the trend line? Trend line is that the general trend, whether for this particular variable, what is the variable? Car sales in units. Has it gone down or has it gone up over a period of time? In our case, from 50,000 units, it's gone up to about 85,000 units. Correct? So this is the trend line. In our case, the trend line has moved up. Correct. So generally speaking, it is steadily, car sales figures have been moving up year on year on year. Fine. This is what you call as a trend line. Second thing which we saw over there is, first was trend line. Second is what you call as cyclical. Okay. What is this component now? Cyclical, as the name suggests, is the cycle. So within, let's say from 2000, the beginning of 2000 till 2000, the end of 2000, suppose it's here, you'll find out car sales has gone up and also come down. Likewise for 2001, gone up, come down. 2002, gone down, then gone up. So there's cyclicity. That is what is called as the cyclical component of this. It is not steadily going up in a straight line, right? It's coming down, going up, coming down, going up. it might be more jagged than this. This line might have been a lot more like this also. In our example, we have drawn pretty smooth curves, right? It can be much more jagged. So suppose you're taking the figures on a monthly basis, this might be much more jagged also, the lines. Okay. So, but anyhow, there's the cyclical component. That is what is called as the cyclical component. So we know what is trend. Trend is the general pattern over a period of time, the average of that, the fact that this has been moving up over a period of time, right? Cyclical component is this component, which has gone up, come down, gone up, come down, this part. Then there's what you call as a seasonal component. So where do you have this seasonal component is you think about an industry. Okay, I'll just clear off a bit of this maybe. Okay. Now, as I was discussing, there's the seasonal component also. What is the seasonal component? For a lot of industries, what might happen is the sales volumes might be very high in a particular season. And in some other seasons, there might be a slack. There might not be too much of sales happening. What might be an example? One of the examples might be when there's some festival. And because of the festival, there are a lot of discounts. So in India, we have Diwali during September, October, November, those kind of months, right? So moment that happens, there are a lot of discounts there. And automatically what will happen? The car sales will shoot up. Not only car, it can be any other thing also. Any consumer durables like a TV, a refrigerator, a washing machine, any of these, you might see there are heavy discounts, and that is why the sales in number of units will jump up, will move up, right? So seasonality, the seasonal component is within a year. Suppose we take the year 2000, let's say 2000, and we check the figures for January, February, like this, till October, November, December. So suppose January, the figures were at somewhere around 50,000, as the graph suggests here, 50,000 when it started. Suppose in February, it went to 52,000, kept moving up. In October, let's say it spiked up to about 65 because of the heavy Diwali discounts. And after that, it again started slacking. It started moving, went down to, let's say, 50, and then to, let's say in November, it moved down to about 55, and here it moved down to about 52. So within the year 2000, this is the year 2000. If you check the monthly figures, you'll find out that there's seasonality. It went up like this. In October, it might have shot up, then came down, and then settled. Okay. So there's this kind of seasonality within a particular year, depending upon which industry you're working for. This is, let's say, October in our case. Why? Because of the Diwali discounts. Because of the Diwali discounts, the sales figures might have gone up. So that is what you call as a seasonal component. So likewise, you'll find out that many things which are bought only during the summers, let's say air conditioners, let's say ACs, air conditioners, right? Sorry. Let's say something like an air conditioner. You'll find out that during the summers, the sales will be much higher. And then during the winters, the sales will go down. So that is again the seasonal component. So in that case, so during the months of, let's say, June, July in India, when the summers are there, this will move up. The sales figures will move up. And again, after a period, settle down. Maybe by December, really goes down. Fine. So there's a seasonality. Though this cyclical movement might be for a year or beyond a year. So the cycle, which is starting here and maybe completes here, may not be within a single year. The cyclical component might not be within a particular year, but the seasonal component is always within a year, typically speaking. Okay. And then if we check, there's this last component causes irregular. As the name suggests, there are some movements which just happens without us being able to explain too much about it. That is what is called as the irregular component. Okay. These four components, it's really cluttered, this whiteboard now, but this is what there might be these four components in a particular graph when you're trying to check a time series forecasting. Okay. Trend, which is this line. Cyclical, which is this cyclical movement. Seasonality, as we have discussed, it depends upon which industry you are in. Certain months, the sales might be high. Certain months, it might be low. And then irregular, something which we cannot explain. Okay.